All right. We have been talking about exponential and logarithmic functions to this point. I think in problem set wise, we should have been able to go up through 98. Today, I want to start with any questions you guys might have. Is there questions from the problem set or other things before we kind of wade back into where we had left off? Yeah, sure, Aaron.
It's not actually a problem we have. It's just when are we doing the test for this chapter? Like next week?
Yeah, it's looking like it'll be a next week test, not a this week test.
All right.
Okay.
Maybe we could skip this chapter too, like the juniors, you know?
Like the juniors, you know?
Yeah. I feel like everyone would be happy for that. And then just put it on the final.
No,
Yeah, don't put it on the final. Like,
Oh, so just we'll do it for the sake of just not really doing it?
Yeah.
I mean, like, with break, I don't think it's fair because, like, I don't remember anything.
That's good, because that's part of what we're going to do today is kind of revisit.
Even before break, I didn't know what I was doing.
Okay. Well, that's okay, because this what we're doing right now is answering questions, so we can address some of that, like
Carry on, I guess.
not know what we're doing. This. Here's I don't want to make this hard. I don't want to make this impossible. And you make a good point. We did half of this chapter before break, right? So it is hard to kind of remember that stuff. And when it comes time for test time, well, we can take that into account. But I think having like the half sheets, I think probably helps that, because you're able to like go back and, add in the things that are maybe more from the first half than the second half, that are maybe a little less familiar because it was from before break. So like we can talk some more as it gets a little bit closer, but like I don't want to make it so it feels like I'm setting you up for failure.
Okay.
Right? Like I don't want to do that. But we do need to it is important to me that we still try to learn this stuff, and we're still trying to do it. I know, but here's the thing. Like, I understand where you're coming from, and like you have some good points. Like, my answer is really no, but like we can find some place that's maybe in the middle. I don't think you're expecting a yes, but
No, I wasn't.
like. I hear you, and I think that's important, right?
Yeah.
Sure. Okay. So, we ready to, are there like specific questions on things that we want to circle back to, or is it, no?
I'm personally still trying to get a block.
I understand. I understand that everybody's still.
That's what. Yeah.
Okay. So previously, we had defined a logarithm, right? You remember the definition for logarithm? So if we have the exponential equation, b to the x is equal to y, that is the same as x equals log base b of y. Where again here, that value for b has to be greater than 0 and not equal to 1. As a result, since you're taking a positive number to a power, what kind of result do we have to have for y if you're having a positive number to a power? Can you get a negative if you take a positive number and raise it to some power? No. Can you get 0?
Yeah.
No. Take a positive number and raise it to a power? No. So again, y has to be positive. And these two pieces from the exponential form are going to carry over and also be true in the logarithmic piece. So when we're talking about logarithms, the piece here that becomes really important for us is that the input for a logarithm has to be a positive number. You can't take log of 0, you can't take log of a negative. Those things are just undefined. Everybody's okay? Is this just trying to recap some of these things? So we had some general properties of logarithms that we talked about. So we had something like log base b of b, well, that's just 1. Log base b of 1 is 0. Log base b of b to the n is just n. So those were kind of general properties that we could use to kind of work with our logarithms. We had a couple of special logarithm properties. And that was the last thing that we had looked at. Those were the product, power, and quotient properties. Okay. Does that kind of look familiar? Today, what I want to do is I want to start talking about how we use logarithms or exponents to solve equations. So some of the tools that we're going to be using are going to be these properties that we've just reviewed. So the simplest kind of exponential equations or logarithmic equations we can solve are going to be based on using these one-to-one properties. So the first one says for an exponential equation, we can say if b to the x is equal to b to the y, then x is equal to y. So for example, if we know like 2 to the x is equal to 8, we know 8 is 2 to the third, so then we can say that x is 3. Everybody's okay with that idea? So very obvious kind of property. We can say the same thing for logarithmic properties. So if we have some logarithmic function, if I have log base b of x equals log base b of y, then x has to equal y. So let's kind of look at some examples where we use this, or use these properties. All right, so let's say we have 14 times 1/3 to the x minus 1 equals 126. So this is a solving problem. Remember, when we're solving, we're kind of running the reverse order of operations, right? What should be the first thing that I do here to solve this equation? Okay, can I multiply 14 and 1/3 together? No, why not? Yes, very good. So there's two ways that we can multiply numbers together. So if they have the same exponent, we can multiply the bases together and keep the exponent the same. Or if they have the same base, we can keep the base the same but add the exponents.
What do you mean by base?
So like this is the base of the exponential, right? Is the thing that we have a power of.
Yeah.
So here I have 14 to the first times 1/3 to the x minus 1. The bases are different and the exponents are different. We can't multiply those two things together. Okay. So these are good things to review, right? This is what I want. So even if we, we say something, it looks like something we can do, we can review, yes, whether we can or we can't, and why we can or we can't. So that's great, right? And that's a very common, mistake I see students make on this, is to multiply two things together that you can't multiply together. So we can't multiply 14 and 1/3 together, but what could we do? Yeah, let's divide both sides by 14 and just get it the heck out of there. Everybody feels okay with that? Okay. Now what I'm going to try to do is I want to try to rewrite these two so that they have the same base. So I can either try to turn a 1/3 into 9, or I can try to turn the 9 into the 1/3. Me personally, I think it's a little bit more obvious changing the 9 into the 1/3. I have to muck around, I think, a little bit less because there's not another exponent already stuck onto that. But you could do it the other way and it wouldn't be wrong. Okay, so what can we say about 9? Again, we're trying to make 9 look like have a base of 1/3. What can we say about 9? Well,
You want it equal to 1/3? Like not equal.
well, I want it to be like
Like 27.
1/3 to the something, right?
1/3 of 9 is 3.
Okay, let's start here. Well, how can I rewrite 9 with a base of 3?
27 over 3.
Okay, when I say base, I want like an exponent.
3 squared.
3 squared, right? Everybody agree with that? Like I'm trying to make an exponential here. So I can make a 3 squared, right? Everybody's cool with 9 being 3 squared? And who remembers this property of exponents? You guys remember that? That a negative exponent makes a reciprocal? So I'm going to do that here. So I know 1/3, the reciprocal of that is 3, right? So because I made the reciprocal and then made the exponent negative, it's like I did nothing at all. Everybody's cool with that notion? Why would I have wanted to do that?
Just want to get that fraction back to like a normal one because it's easier to work with.
Well, the bases are now the same.
Yep.
That's the key, because if the bases are the same, then the exponents have to be equal. And I can just add 1 to both sides. And I'm done. Let's try that again.
Can you explain, how you got 1 over 3 and then into one more time?
Yeah, sure. So I have this, right?
Yeah. So you use that for,
And I'm going to use this rule up here. So if I make both the reciprocal and the exponent negative, because the negative exponent makes a reciprocal, that's the same thing as just 3 squared. Because, Leo, if I think about it this way, the 1/3 to the negative 1 is just 3. So it's like I've done nothing at all. I've just written it in a weird way. So the takeaway, Leo, the thing that you want to remember is I can change this to a reciprocal by adding the negative exponent. So if I make a reciprocal and add the negative exponent, it's still the same thing. So for example, if I had 5 squared, I could rewrite that as 1/5 to the negative 2. Right? Or if I had 1/2 to the negative 2, I could write that as 2 to the positive 2. Does that?
Yeah. Is that just like the same rule that applies to everything?
Yes.
Okay.
Yeah, so I'm just using this rule in kind of a clever way.
Probably makes sense, but like, I don't understand the equation very well.
Okay.
But keep moving. Thank you.
Yeah, I got another example up my sleeve, so
Cool.
we're going. We'll see it again, and maybe again, if it's not quite there, or you're not quite sure after this one, like we can stop and hash it out a little bit further. Okay. Here we have 12 times 3 over 2 to the x over 5 equals 27. I think this one's actually a little easier. What do you want to start by doing? Divide by 12. Right, I want to get that exponential piece by itself on the left-hand side. So let's see. I can reduce 27 over 12 because they both have a 3 in it. So that would make 9 over 4. And here's a case where really important for these kinds of problems, you definitely want to leave things as fractions. A decimal is not going to be helpful to you here. So those of you that are anti-fraction, just make decimal whenever possible. Don't do it for these problems. We kind of need the fraction. Okay? All right. So the next step, now that I have the exponential by itself on the left-hand side, is I want to make the bases match. So the base on the left is 3 over 2. The base on the right is 9/4. Do you guys see a relationship between 3 over 2 and 9 over 4?
Nine fourths are the square root. I mean, the square brings up to it.
Excellent. Yeah. So 9/4 is 3 over 2 squared. Right? Because 9 is 3 squared and 4 is 2 squared. Do you guys see that? And hey, what have we done? The bases are the same, so what can we say? That the exponents are equal. Is that? Okay. Leo, we didn't have to use that same trick we used last time. Was this one better or worse?
Yeah, that was better.
You're not convincing me.
But yeah, there's just no way that I'll ever have that problem with yellow and then find a solution like that.
Okay.
Without a lot of practice.
Okay. So here's an alternative. Let's say we got to this spot, right? And you probably feel comfortable getting to that spot?
Yeah. Easy.
Okay. What's the alternative that I could do here other than making the exponent, the base of the exponentials match? Because there's another way I could use to solve this. The other tool would be using a logarithm. Okay? Which logarithm do I want to use? Log base 2, log base e, log base 17, log base 7 over 5. There's infinitely many choices, but which one would be the best one in this situation? Well, the answer is easy. You want the base of your logarithm to match the base of your exponential. What's the base of our exponential in this case? 3 over 2. Everybody see that? So that's the logarithm that I would use to both sides. So far, so good, Leo?
Yeah.
Does that seem reasonable as something you could come up with? You're just using the base of the logarithm
Yes,
to match the base of the exponential
Yes.
every time.
Yes, for sure.
There's nothing tricky. There's no like mental math like number fact going on.
Yeah.
Always the same. So why did I want to do that? Because that base of the log, or that log base 3 over 2 cancels exponent base 3 over 2. So I'm left with that. If I multiply both sides by 5, I have that, which is now a calculator problem. So I'll do 5 times, and then do you remember how we typed the log of any base into our calculator? That's okay. We talked about it before break. I don't expect you to remember. We press the math button, and then you'll scroll down to the bottom, and you're looking for the log base command. So that'll allow you to type in any number you want. Down here is the log base, provided that it's greater than 0 and not equal to 1. So 3 over 2. And then I'll just type 9 over 4 in there. So now it looks just like it does on my sheet of paper. And I hit enter, and there's the same 10 that I got before. So this is also an acceptable alternative way of solving these kinds of problems that doesn't rely on like basic arithmetic, like recognizing like, oh yeah, that's, you know, that thing squared, or like, oh, that's, you know, like a negative 2x, you know, like you don't have to do that. You just use the logarithm and move on, and
Yeah, I like that way better.
the logarithm takes care of things for you.
Will you ever get a decimal?
Sure, you could get crazy decimals. Absolutely could happen. Right? So just for example, if we did the same problem and it was just like we had a 7 over 4 over there, nutso decimal, right? And in fact, that's an irrational number. Like that can't even be written as a fraction.
Yeah, but if you were to do it the other way, you get a fraction, right?
No.
No, you wouldn't.
No. In fact, if it was 7 over 4, it would be impossible to do it the other way. Well, not impossible, but you'd have to use a logarithm anyways. So, like, it just kind of defeats the purpose of trying to do it the other way. So using logarithm in a way is a little bit more versatile, because you can't run into a problem that it's like, yeah, I can't rewrite 7/4 says a power of 3 over 2 without using a logarithm. So, okay. Does that better? Maybe a little? Sure. And again, as we're doing these, we can do them both ways, and we can talk about the pros and cons. Okay? Again, when you're doing things for me, any way is acceptable, right? So, all right, you guys ready for something tricky? Probably not at 8 o'clock in the morning the day after break, but we're going to do it anyways. So we have 3 to the x plus 3 to the negative x, divide by 4 equals 2. Lots of scary things in this. What does your instinct tell you is the first thing to do? I want to get rid of the fraction. Let's multiply by 4 on both sides to clear that out of there, because, hey, if I can get rid of a fraction, that's usually a positive for me, right? So, you know, just multiply both sides by 4. That seem okay to you guys? Okay. What's the next scary thing going on here? I'll tell you what I don't love is the negative exponent, right? Why don't I like that negative exponent? What does the negative exponent really mean? It's a fraction also. So let's get rid of that negative exponent and get rid of the fraction at the same time. Ooh, Mr. Kulik, now you're speaking my language. How am I going to do that? Here's the trick. I'm going to multiply both sides by 3 to the x. Why 3 to the x? Well, let's see what happens. When I multiply this, what do I get when I do 3 to the x times 3 to the x? Does not give me 9x squared. No. So remember, let's do it over here.
That's why I said it underneath my breath, so you can hear it.
Well, that's okay. But here's the thing. Just say what you think you would do, because it's important that we because what you're thinking now is the same thing you're going to do on the test, right? And if we say the wrong thing now, it gives a chance for Mr. Kulik to correct you so that we can at least have seen the right way to do it, right? And it's like, okay, my initial instinct was wrong here. That's okay. Don't expect you to have the initial instinct correct. Okay? So that's okay. It's okay. That's what I'm looking for, is for you guys to do this. So remember the way that we multiply two exponentials when the bases are the same. So we add the exponent. So this would be 3 to the x plus x, or just 3 to the 2x. It's okay with that? That rule look familiar? So I'll do the same thing then, and we're going to multiply 3 to the x now to 3 to the negative x. So that's going to be 3 to the x plus negative x. And what is x plus negative x? Zero, right? What's 3 to the 0 equal to? 1. Remember that any non-zero number to the 0 power is equal to 1. And then can I do anything with the 8 times 3 to the x? Nah, man, right? Nothing to do with that. So that's just going to kind of hang around for the ride. Everybody so far so good? Okay. So are any of these things that I have like terms? Is there anything I can combine together? The 3 to the 2x, the 1, and then the 8 times 3 to the x. Are any of those like terms that could combine together?
I just want to make sure you can't combine 3x and 2x, right?
Correct.
Okay.
Yes, very good. So we cannot combine a 3 to the x and a 3 to the 2x because the exponents are different. Excellent. So there's no like terms here to combine. Everybody agree with that? So what we have is, I'm going to move that all onto one side. What kind of an equation do we have that has like 3 terms in it like that? Quadratic. Would you believe that this is in the quadratic form?
Yeah, I see.
So where's the thing squared?
3.
The 3. What do you mean the 3?
That's a 2, right?
Yeah. So it's not the 3 though that's squared. It's the 3x that's squared. So remember this property of exponents, the exponent of an exponent property. X to the a to the b is x to the a times b. So I can think about this as 3x squared. And now it looks like quadratic. And to be even more explicit, so it really looks quadratic, let's replace those 3 to the x's with y's. And now this just looks like an algebra 2 problem, right? Was not expecting that to turn into a quadratic on me, but I believe that if you had my algebra 2 class last year, I made a point of saying like these quadratics are like the most important single skill you get in algebra 2 because they show up everywhere. Wow, look at that. Showing up when I didn't expect it. So how do we solve a quadratic? What are some of the ways that we had to solve one of these things?
The quadratic formula.
The quadratic formula is one of them. Or factoring would be the other major one. Now, typically, when the leading coefficient is 1, factoring, if possible, would be the better method. What would I need to check to see if this could factor?
Isn't it like adds to 8? So how does it go down?
Multiplied to give me the constant,
Okay.
and then add to give me the linear coefficient. Are there 2 numbers that multiply to give me 1 and add to give me -8?
I don't think so.
Yeah, not integers. So what should we do? Quadratic formula. Okay, who remembers the quadratic formula?
Well, I do.
Okay,
It's x equals -b plus or minus the square root of b squared minus 4ac over 2a, I think.
that sounds good. Okay. So here, my value for A is 1, my value for B is -8, and my value for C is 1. So when I plug that all in, I have y equals 8 plus or minus the square root of 64 minus 4 over 2. So 64 minus 4 is 60. And the square root of 60 is 4 times 15, right? Or 60 is 4 times 15. Everybody agree with that? Why is that particularly useful? Because the square root of 60 will be the square root of 4 times the square root of 15. And what's the square root of 4? 2. So this will reduce down then to 4 plus or minus root 15. Is that my answer, though? Nope. What? Why not, Mr. Kulik? Well, that's the solution for y. What was our problem, though? The variable in our actual problem? Go all the way back to the beginning. We have x's. Oh, no. So really what we have now is 3 to the x equals 4 plus or minus the square root of 15. Is everybody okay with that? So I just, at one point I replaced the 3 to the x with a y, now I'm putting the 3 to the x back. So this is really two equations, right? 3 to the x equals 4 plus the square root of 15, and 3 to the x equals 4 minus the square root of 15. So far, so good? Am I going to be able to rewrite 4 plus the square root of 15 as a number with a base of 3? Don't think too hard about it. It should be obvious.
Yeah. That could be base 3 for sure.
No, I don't want to do that.
No, it can't be.
No. What am I going to do instead? I'm just going to use a logarithm to solve this equation. Which logarithm do I want to use?
Log 3.
Log base 3. Absolutely. I want the logarithm that matches the base of the exponential. Now I want to point out to you guys, oops, it's a minus sign now. We do need to be a little bit careful because it's possible to get extraneous solutions on these kinds of problems where we have the quadratic. I don't in this case, but if for whatever reason, if the answer we get here these are negative numbers or one of the numbers is negative, you can't take the logarithm of a negative number. That part is just going to give you an extraneous solution. But this one is fine because 4 minus 15 is still a positive number. So I'll do math, log base 3, 4 plus square root 15. So that's 188-ish. And then I'll just recall that and make it a negative. And I got negative 188-ish. And those are my solutions. Youf, Mr. Kulik. Not sure I would ask you guys to do that on the test. It'll show up in the homework. But that's tough, right? All right. What about some logarithmic equations? So previously, we've been solving exponential equations, right? This here is a logarithmic equation. What do I want to do first? What does your instinct tell you is the first thing that I can do or should do here? That's absolutely the first thing that I would want to do. Yes. Let's get that logarithm piece all by itself. Okay. How about now? What do we need to get rid of next?
The log, right?
The log. Very good. So how do we get rid of a log?
Well, we multiply by the reciprocal. No.
Don't we need to use
Not multiply,
Divide.
not divide. It's not,
Subtract.
well, log is,
Oh, you square rooted it.
lo-
Oh.
a log is an operation, right?
Yeah.
So it's not a number. What is going to cancel out a logarithm? What's the opposite thing of as a logarithm?
We'll log on the other side.
It's not a logarithm. It's not the opposite.
Oh, the inverse logarithm.
Right, which is
ln.
ln is not the inverse log. That is a type of log.
is that like log with a base or something?
We use an exponent base, right? So just like we saw before, we used a logarithm to cancel the exponent base. Down here, we're going to use an exponent base to cancel the logarithm. So the question is, which exponent base? Do I want to use 2? Do I want to use a half? Do I want to use 17? Do I want to use 15.8? What number should I use?
1. That's very easy.
Well, you can't have an exponential with base 1, remember? Well, you could use 2. I would not, because there's a way to make this problem as easy as possible, which is always our goal. When we picked our logarithm, how did we pick our logarithm? So we went back to this previous problem. Why did I pick log base 3? Right here. Why did I pick log base 3 there?
3 is an easy number.
Because it goes into 15.
It had nothing to do with the 15.
So then that has to do with the 3x.
Yeah, 3 to the x, because that was the base of my exponential. I wanted the base for my logarithm to match it. So down here, when I pick my exponential, I want it to match the base of my logarithm.
Oh, so x to the 2 is going to be a base.
Nope,
X is.
nope,
2 is.
nope. What's the base for log?
10.
10! So remember, we had 2 special logs. Log base 10, we just write as log. And then log base e, we write as ln. So here I'm going to use an exponent base of 10, and I'm going to write that like exaggeratingly large. Why am I doing that?
So we can see it.
I don't want you to confuse it with multiplication, because we're not multiplying both sides by 10, right? We're not doing 10 times 2 on the right side. We're doing 10 squared. So those cancel each other out. So what can I say there?
Oh, the squares cancel out too.
Yeah, x is just 10, right? I mean, if you want to think about it square rooting both sides, that's fine. Or you could just look at it and be like, oh yeah, x squared equals 10 squared. Well, x has to be 10. Mr. Kulik, does it get harder than this? Of course it does. When do the quadratics come in, Mr. Kulik? Oh boy, Mr. Kulik, this thing looks like a big hairy mess. Well, you know, it's fine. what should I do first here? This is quite tricky.
Well, in this case, we don't need to divide by anything, do we? Can we just go straight to getting rid of Li? Or no?
Well,
Because we only have 2 on the right side.
there are 2 things that I would do before I started trying to get rid of the ln's. And what I want is I want only a single logarithm on the left side and only a single logarithm on the right side. So right now I have 2 logarithms on the left-hand side, and then I have a coefficient on my logarithm on the right-hand side. I want to get rid of both the addition and this coefficient before I try to get rid of the logarithms.
Divide by 2.
Well, that's just going to move the coefficient
Oh, yeah.
onto the other side. That's okay.
Wait, it's a cool dumb question. Can we just add both on the left side of the equation? Can we add those together? Because it's 3x minus 2 and they both have the same basis.
So
Or no?
is log of 2 plus log of 3 log of 5 is what you're asking, right?
Yeah.
That's basically what you're saying, right?
Yeah.
If this is true, then I should be able to do what you're saying.
Right.
Well, let's just do it let's do it the dumb way and just check, right? I'm going to fire up my calculator and see if those 2 things give me the same number. No. So it can't do that. And again, if you have are you taking a standardized test? And you're like, I wonder if algebraically I can do this thing. Just try doing it with numbers and see if it works. You know what I mean? Like we just tried there. So we can't do what Joe suggested. And that's okay. I mean, this is the point of talking through these, what does your intuition tell you? Because that's probably the thing you're going to try on the test. And if we can sort out those kind of misconceptions now, less likely we're going to want to do them again. Let me give you a hint. We've mentioned the tool that you need already. Way back in the beginning, we need to use these power, product, or quotient properties.
Probably the product property.
The product property will take care of the left-hand side. And which property do I need for the right-hand side? The power property. Excellent. Does everybody kind of see that? Scroll, 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 scroll. So the product property is going to give me this. And the power property gives me that. And just to make our life a little bit simpler, I'm going to go ahead and FOIL that stuff out there on the inside so that there's not a whole soup of parentheses sitting in there. Is everybody okay to this point? Okay. Nobody's objected yet. Feel free if you need to jump in and be like, yo, what did you do? We can always talk about it some more. All right. Now, Joe, it's time to get rid of the logarithms. So what exponent base is going to cancel the natural log?
10.
Not
Is
10.
it E?
It's E, yeah. Remember, log base E is what ln is.
After the ln.
Mm-hmm. So I'll do exponent base E to both sides. And again, I write it really big and exaggerated so that hopefully it's super clear that I'm not multiplying here. So what does that do? Gives me 3x squared minus 5x plus 2 equals x squared. Huh! What does this look like?
Quadratic.
It looks like a quadratic. Mr. Kulik, again? They're just coming out of the woodwork all over the place. What's the first thing we should do to solve this quadratic?
Factor.
I would do something before I tried to factor.
Use the quadratic formula.
I would you do something before I do? I got to get everything onto one side because it has to equal 0 before I can start solving. So let's subtract the x squared from both sides. And then we could either try to factor this or try to use the quadratic formula. Now, in this case, the leading coefficient is 2. It's not 1. So if I'm able to factor, which maybe I'm able to tell right away, maybe I'm not, I'd have to do the long factoring, which is a pain in the tuchus and probably not any shorter than just using the quadratic formula, which is what I would do in this case if I were you. Is that okay with everybody? All right, so negative b plus or minus square root b squared minus 4ac all over 2 times a. So what do I get there? 25 minus 16 is 9. So that's 5 plus or minus 3 over 4. So 5 plus 3 over 4 is 2. 5 minus 3 over 4 is 1/2. Am I done? No.
No.
But Mr. Kulik, I solved for x. Those are the answers, right? Well, they might be extraneous. Oh, Mr. Kulik, this problem doesn't end. So we do need to make sure we're checking. Every logarithmic equation that we solve, we do have to check to see if we are getting extraneous solutions. The check is relatively easy, though. So if I check 2, all I need to do is go back to the beginning, and I need to check that when I plug 2 in for x, the answer is positive. So 3 times 2 minus 2, positive. 2 minus 1, positive. 2, positive. 2 works, no problem. Now let's do the same thing for 1/2.
Nah, I don't think that was gonna work.
3 times 1/2 minus 2,
That's negative.
negative.
No way.
Boo! So this one is extraneous. We stop as soon as we find one of them that doesn't work. Even if some of them do. If one of the logs gives you a non-positive result, extraneous. Get it out of here. Get out of here. Looking around the room. Do we need to be done? Okay. We can stop here. This is a reasonable place to stop. We'll finish this section next time. At this point, though, you guys should be able to do up through. Let me just look here right quick. Ooh, goody. Can go 99 through 130 are all doable.
So cool. May I go wash this cup real quick?
Yeah,
Cool.
sure.